Alright, hello everyone. And welcome back. Let's get the graphic out of the way. And once again, I hope I have my audio settings somewhat decent. Do let me know in the chat if you'd be so kind, if you can hear me alright. I have sort of like a mental checklist these days of like what I need to make sure. All of the different toggles and audio settings I need to make sure are in the correct place before I start streaming. But still, hope you're all doing all right. This is a little bit of an unplanned stream in the sense that I was actually planning to do this yesterday. But preparing for the stream, essentially all of yesterday just turned into an absolute shit show on my part. So here we are, one day later. The plan is basically the same as I was planning to do yesterday. But yeah, we'll see. I'm hoping I'll fix all of the issues I was having yesterday with this. You can see that I've actually used the slightly more rare game dev visual. Engine dev visual rather than game dev this time around. Because I am indeed planning on doing a little bit of engine dev today. Yeah, okay, we do have audio. I just turned it off earlier. We do have audio. Hopefully you can all hear the game audio as well, and that the levels are somewhat good. This is a much earlier stream in the day, so I kind of expect the turnout to be perhaps a bit smaller than it was on Friday, when I streamed actually kind of late, finish time. I would expect a lot of the Western world to sort of still be asleep or just waking up, not having the mental energy to deal with game development. But regardless, you're welcome if you have found your way here. What's up, Aexadev? Welcome to the stream. And Fox Fuxol says, sounds good. Thank you for the report. It's always appreciated. And do let me know if it changes. Right, so what are we going to do today? Well, so there's one feature on the engine side, on the engine level, that I've been sort of wanting to add for quite some time now. It's kind of like related to modding a little bit, but it can also just be very, very handy for general development, and it's something that I kind of have use for myself in the work that I'm planning to do basically next week. So if you've been around for a little while, you know that I have a mod that allows me to create a flying scout like this. And this flying scout vehicle basically takes the standard scout, which we have over there, which is part of the base game, right? And then it adds a jetpack onto it, which means that we can fly. We can soar through the air like a bird, like this. There's no like directional controls or anything in the air, so if you wanna fly, like move forward in the sky while driving, you have to kind of pick up some speed and then engage the thrusters, and yeah, it flies like a glove. And yeah, we have some blockers here, so you don't actually fly off the level there. Hello, Zidlo1. Welcome to the stream. And yeah, we don't have any sounds for this yet. This is actually something I'm gonna be working on also, kind of relatively soon. I was thinking we would actually add like a completely procedural jet burst sound for this thing during some stream. But I need to do a little bit of tech work for that to be able to like take place. So that's all well and good. The thing with this though is that like with the current system you can kind of only really add components to existing game types. So what this mod actually does is that it takes the scout vehicle and then it adds the jetpack to that. It can't really replace any components. You can't say like, okay, yeah, well, I want the scout, but I want to switch out the mesh for another mesh or something like that, right? And that is something that I've been thinking about. I kind of want to do, or I've been thinking about wanting to do for a long time. I can actually probably fly over these blockers here. Yeah, like this mod with the flying vehicle, this just like breaks the campaign completely. You know, yeah, we don't even have any collisions there, so you can see we're just going out of bounds very easily. And now it's actually super tricky to get back because we can't really control it in the air, can't really steer it in the air. I don't think these have collisions either. Nope. So yeah, that's a bit of a problem, isn't it? Not really though. I mean, you're not really supposed to use these mods in the campaign. Although you can if you want to. If you just want to break the campaign completely, you can do that. Right, Swedish people can't pronounce S. Alright. Okay. Yeah, I'm not Swedish, by the way, I'm Finnish. I am a Finland Swede, so it's sort of like a strange mix of both of them. I did get some feedback on my recent video for my SS though. And Overloader 7900 says, fun fact, when you split values into two groups in a warp, you can write the groups to two ends of a buffer in a shared memory and not have any bank conflicts. That's a pretty sort of low-level little factoid in GPU programming for you right there, if you if you didn't know that. Thank you, Overloader. I live in America, but I'm up late normally, so I can catch a stream sometimes. Yeah, sometimes I actually stream kind of late here, just like, you know, for many reasons. Sometimes it's just like, you know, I've had some stuff to do during the day, and then I just don't have time until it's fairly late here. At which point it is like morning or you know, or well, early morning or late morning in New York slash, you know, Seattle, to take a couple of cities from the different ends of the United States. But yeah, I'm happy to be able to provide some entertaining content there. Right, so what was I talking about? I was talking about being able to actually replace like a component on something existing, and we would basically do that in this stream. So if we go and have a look at the blueprint system, whoop, not to be confused by, or confused, you know, with, mixed up with the Unreal Engine blueprint system. This is not at all like that. Blueprint. The blueprints in Basis is basically like a list of components along with their properties and some sort of packaging data. So you have, for example, a game object type here called vehicles test vehicle. You also have a game object type called vehicles scout. And we can see a preview of the thing here. Without wheels, funnily enough. And basically what you can do is you can have a base type. You can see the thing here. I can't zoom this, by the way, because this is just classical Win32 controls. So no zooming, but hopefully you can manage to figure out what's going on. So a vehicle can be based on another vehicle, and that is how we actually have the flying scout be based on the scout vehicle. I think none of these actually have like a base type. No, all of them are just like listing all of their components themselves. So basically this base type field is empty here. But if you have a base type, what happens is basically you get all of the components from the base type, and then you get to add components on top of that. So I think we have, for example, if we go and have a look at the gameplay blueprints. This is actually something that we looked at in the stream from Friday. We have a gameplay game master base. So this is the base type for a game master. Game master is essentially like a component that, you know, defines the game type. So if you had like a multiplayer game, you might have like a deathmatch game master and a capture the flag game master and single player campaign game master, and it sort of like sets up the rules for that. So default game master just adds one more component to it, and then it has the base type, you know, game master base. Campaign game master does the same thing. It also has the game master base as the base type, but it adds a campaign game master component. And we added the sandbox one in Friday. So what I did, well, first of all, I made some changes to this editor. If you've seen, especially these vehicle blueprints in some previous streams, it can take like ages for these to load, and that's basically because Windows Forms isn't really meant to be used like this, where you just have like lots and lots and lots of dynamically created components like this. Some of these components actually have quite a few fields. You go have a look at the mother, for example. The mother vehicle's dynamic body transform component just takes ages to open because it's a really, really huge component. You can see with all of these like convex hull points and everything added to it. So you had like a couple of thousand Win32 controls being created in one go. So what I did is essentially I added this expand and collapse feature here to this. Which also just makes it easier to, you know, scroll through the whole list of components and you know, find what you want. And I found out some very confusing and surprising things about the Windows Forms flow layout panel, which manages like the order of this stuff. I'm not sure actually I've fixed all of the bugs there yet. I had some very confusing bugs where the order of these guys just kept changing. But I think I might have fixed everything, but we'll see. We'll see. Replace just means an inventory system that makes sure conflicting meshes don't appear together. What? What? What do you mean inventory? Like, are you like, okay, first of all, are you talking about the replacing components? Is that what you mean? That's not like a game level thing. That's a tech level thing, in the sense that like it's only meant for the developer, and it's basically meant as, you know, if you have a type that is based on another type. Let's say you wanted to base something on the Game Master base here. You know, collision FX manager component, for example. And you had another Game Master like this sandbox here, which is based on on the Game Master base. What if you wanted to replace this collision effects manager component, which is found in the base? You currently can't do that, and that is basically what I meant. So you can't add like another, you know, FX. Oh, that's only a vehicle. Well, let's just add it here for illustrative purposes. If you added another FX component here with some other paths, this thing is just currently added to the list of components. So then you have both that one and this collision FX manager component. So you can replace like a previous one with a newer one. And that's been sort of annoying, because that means that you can't, for example, in a mod you can't replace a mesh that's already there, right? So if you have a vehicle, and we have the scout here, and we can find, if we look here, we can find the meshes. So here's the mesh interior suspension, that's a renderer. Windshield mesh, the chassis is probably up here somewhere, isn't it? Yeah, there's the chassis. Right. So let's say you wanted to create a new type. It's called like scout number 2, but you replace this chassis mesh with something else, right? I mean, we can do it here. We can just, you know, gripper truck chassis, for example. Oh, that's a blockout one. Let's maybe not add that one. Chassis. Which one is it? Probably like... is it like base maybe or something? Gripper truck. It's called main. Yeah. So here we go. Here we have a gripper truck with the scout textures. Obviously the textures don't match because the UV map doesn't match. We still have like the windscreen and everything here, windshield. So what if you wanted to do something like this? You can't do it currently without just creating a new type completely, and which doesn't have this mesh component. Hey Tutu, Fooksoul asks, how does this tool know about your components? Is it made in your engine, or does your engine export the definition file? It doesn't currently export a definition file, no. No, you can actually see here, like vehicle drivetrain component. It says actually UI definition missing for this component type. Add a UI definition for the component type to modify its properties. You don't need to actually have anything. This thing works just fine if you promise it that you have a component. Right, so if we add a component here and we call it a non-existing component, and we call it, the name of it is doesn't exist, right? You can just go like, yes, I want that, and it tells us that the type non-existing component is not registered. I sure want to use it. Yes, we are sure. And we can see it here, non-existing component. So this obviously, like if we try to use this in the game now, it will tell us that, like, what are you doing? So it doesn't actually need to know about this, because what this thing actually outputs is just the JSON data. So we can copy the JSON data from there, and we can just paste it in here. And here we can see, here's our component of type non-existing component. So that's completely fine as long as you actually have the thing. As long as you have the thing registered in the game, it will work. Then the way that these things, you know, this mesh component, for example, has these properties here that you can set. And also, if you go here and add a component and you start typing mesh, it will show you a bunch of components that you actually already have, you know, registered. So if we add a new mesh component name is mesh, that's fine. We get a new mesh component and we get all of these settings here. This comes from a UI definition that you actually you need to write then for that mesh component. And here we actually have one on the right hand side. This is a means vehicle component. So so yeah, this is TOML. This is the data format for this, and this could probably be generated from the code somehow. Yeah, but I don't do that yet because like there's a lot of sort of flexibility in, you know, both how you actually want this thing to write the JSON data. For example, most of these have this explicit default value thing set here, but you can just leave this out, in which case the value is actually not even written. And then you can, as long as you match your, you know, JSON loading logic on the game side to know that like, okay, if this field is left out, then that means this or that. It basically comes from the fact that I used to just write this JSON by hand completely. So I used to have a lot of shortcuts for like, okay, if this member is there but this member is not, then that means something and blah 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 blah. And just like replicating all of that in some sort of like generated form, it's quite complicated. So I haven't done that yet, but yeah, sure, we could actually probably generate this stuff from a component. That's completely fine. Here's some testing things from yesterday that I went through. So Overloader asks, is the problem removing and accessing elements of the base object? It's specifically like removing and or replacing, right? So if you want to make, again, using the scout as an example, if you want to make a scout that has a different mesh, currently the way it works is that it adds the types from the base, or the components from the base type, and only then does it go in and add the components for the current type. So by the time you've actually, you know, specified something here, the base types components are already added to the object. And there's really no way of telling it that, hey, I actually want this one thing here to replace like an earlier thing, or perhaps not even have it created at all, like removing a component from the base type. So that could be kind of useful to have. And yeah, the other thing that I have done on this editor, another thing that caused me a lot of grief. No, not really a lot of grief. This was much easier to do than the expand collapse thing. Perhaps ironically, is adding like this advanced settings window, which currently just has one single checkbox, but I made it as an advanced settings dialog, which is like a modal dialog here, because I might want to add more stuff here, and I don't want to clutter up this interface any more than I already have. So the idea here is that like if you toggle this, set it to be overwriting, and press OK, you can see here we get this OVR text added after the AI driving component. And basically what this means is that since you have to give a name to each component, this means that if we are basing this type on a base class, which we currently aren't, but let's pretend we are, and that base class has an AI driving component, then this component will replace that, right? And it will be put there in that place. So the order of these components is also important, because like components appearing earlier here in the list will get created before components appearing later in the list. And this is a new thing. This doesn't actually do anything on the runtime side yet. So that's one thing that we're gonna want to do today. And you can actually replace a component with a completely different type of component as long as the name is the same as the type that you actually want to replace. And so if you're trying to replace something that doesn't exist, I think that should probably give it an error and tell you that, hey, you're trying to replace something, but like there was no actual AI driving component here. So exactly the case we have now, where we have this override setting here for something that, there's nothing to override. And what this should allow us to do is make mods for the game that just take a base type, such as the Scout, that's part of the base game, and just adds another mesh to it. Or you can even just like, you can retexture the Scout using this, if you want to. You just have the same settings as the base mesh, but it just uses a different material, for example. Because, you know, if you go look at the chassis mesh here, you have the material is set here, so you might just want to, you know, change that to something else. So, I hope that makes sense. That should be pretty powerful. And this is also very useful because I am planning on trying out a new wheel model for the mother vehicle. For this guy here. And if I don't have this, basically what I'm gonna have to do is I'm gonna have to copy the entire mother vehicle object type just to be able to have, you know, 1 or 2 different components in it. And I don't want to break this one that we have currently here, because this works. It's just a little, yeah, exactly, stuff like that. We have these wheels that sort of like intersect with the geometry a little bit, and then they kind of snap up when an obstacle is right underneath the wheel. And there's another vehicle model that I want to try out for this guy, but I want to wrap it up in a single component and then just replace that one component with a new one and have all of the other things working as they were. And that system should help with that as well, as I'm sure you can imagine. So let's do that. But there's also another thing that I want to do, which is related to this whole blueprint business. Let's shut this down for now, and we're gonna go actually into C++. I'm gonna shut this down as well. Let's hope we don't have to do any changes to the tools. So there's another thing that's kind of stupid, which relates to now we can shut that down. Here we have the mod folder for the actual flying Scout. And so if you have a look at the actual blueprint, we can just look at it here in JSON form. So here's the entire blueprint for the flying Scout. We can see that its base is vehicles Scout, and it has 2 components. It has a Scout jetpack, which is a flying Scout jetpack component. So this is a Zig component that, you know, you as the mod creator will create. And then there's a jetpack mesh, which is a mesh component, one of those guys that we looked at previously there in the editor. And it has some mesh that you have included in your mod, and it has some material that you have included in your mod. Now the stupid thing here is that I need to have a blueprints folder where this blueprint file goes into. And if I don't have that blueprints folder there, this thing just won't work. It will not register that blueprint file at runtime, and that's annoying. And so why is that? Well, we can see that this file is of type blueprint, but actually when these guys are read by the game, they are turned into JSON files. We can see that this is actually a JSON file. It just happens to have the extension blueprint. But for some reason, when I made the system, you know, years ago, I determined that as part of the conversion of this stuff, I'm gonna rename these blueprint files to JSON when they you know, are packaged up for the game, and that way I can just use, you know, the normal JSON reading functionality to actually read the stuff out of them. And that is that's a little problematic, because now they are JSON files. So this one would be, you know, just flying Scout.json here, like this. on the game side. So another question is like, how does the game know is that JSON file actually a blueprint file, or is it just like any old JSON file that you might be wanting to read later on? And so my solution for that was, if you have a folder called blueprints, any JSON file inside of a blueprints folder is treated as a blueprint, and it will be, you know, hooked into the game object system when the game starts. But that's a bit weird, because like then you end up with things like this where you kind of like don't really want to have any folders here at all, except for like a work folder for your Blender files and things like that. But you don't really want to have any folders here at all. You just want to have your files laid out, but you need to have a folder for this just to be able to put this blueprint into the mod. That's stupid. So let's not actually, you know, convert this .blueprint file into a .json file at export time. And that's kind of easy to do, I think. I've thought about this a little bit, but I haven't really necessarily done it all the way through. So we'll see. Maybe this will just be an absolute catastrophe. Okay, this opens up in VS Code. You can see this is a Lua file, but this is actually not. I don't use Lua. I used to use Lua, but this is literally the only Lua file in the entire project. So at some point I just made a complete self-made parser for this very file. It's still called Lua because I get nice syntax highlighting with this, but you can actually find that on the channel. I do it all on video if you want to see how that actually works. And so here we have the entry for the blueprint file. So blueprint files are JSON and are converted to JSON resources for now. We don't really want that. We don't want that to happen. So what happens here is that we have a blueprint operation. You give it essentially like the extension that you want to convert, and then you tell it, okay, let's run it through the JSON preprocessor, and we create a JSON file out of that. And then, you know, you might have any number of these tool steps. At some point, you're probably going to want to generate one or more resource files. So we take the JSON file that was preprocessed. Basically, it removes things like comments and minifies the files and stuff like that. And then it puts it into the sort of final, at the final path where the game can access it, right? So basically what we just need to do here is this, I think. I think this should work. You can just remove that. So rather than talking about JSON files, we just talk about blueprint files. Like this. And that means that, you know, we have this asset server thing which tells us, you know, things like the updated paths to whatever you are converting. Let's shut this down now that we changed the script and open it back up again. And we can load the work folder root. And you can see here that, okay, we are scanning through the entire data for the game. There's some stuff actually happening here, and that is because these things are now actually called .blueprint, not .json anymore. So it should be very obvious now to everyone involved that, oh, okay, these are actually blueprint files. Yay. Now if we try to run the game, it will probably just absolutely blow up. Let's see what happens. Oh, it didn't. And oh, that's actually probably because the JSON files are still there in the cache. So let's destroy the cache. The cache is just found here. double underscore cache. Actually, just rename that one. And again, we'll restart this thing. It's just the easiest way to actually get it to reconvert everything. So now you can see that now it's doing just like a whole bunch of things. It's reconverting 1,200 resources basically. So it'll take a little bit of time to actually get this done. But that should be good. After that, we can be sure that it crashes. I kind of like to, you know, to do it this way so that I can see that okay, now it fails, and then we can go in and actually fix it, right? So let's see. Tutu says, it's been a while since you migrated that Lua thing to the custom thing. It has been a while, yeah. It has been a while, and it was pretty sort of, pretty final actually after that initial video. Let's see. Which one is it? Go here to the channel and have a look. It was pretty well working actually after that thing. Yeah, it's this one, Quick and Dirty Script Parser. So this is like 3 years ago, apparently. August, yeah, over 3 years ago. I think I made some changes to this like right after making this video, because I found some issues that I have done on the stream. After that, I don't think I fixed anything in it. It's just worked. So it was a pretty good outcome in that sense. Right. So now then, to actually load the blueprints, we have a C++ function here, a method called load blueprints, and we have certain blueprints that are loaded in like a fixed order. These are mostly things that are part of the engine that I want to appear first in the list of blueprints, just for like editor's sake. You guys don't really need to care about this at all. But anyway, just to give you sort of an idea, we have a few blueprints that are loaded in this order, and then on top of those we load other blueprints. So get a list of all the blueprints to load. We ask the resource manager, get us all of the JSON documents. And this is now, like, this won't work anymore, right? Because they are no longer JSON documents, because JSON documents end with a .json. So what we want to actually do here is we want to get all of the raw data files. So that's that one, raw data file resources, and then we want to see which one of them actually end with which one of them end in .blueprint. If that makes sense. Let's see, what have I done here? Accept all resources found inside of a blueprints folder. This makes it possible to load blueprints from any resource pack, for example mods, but requires the folder to only contain proper blueprint JSON files. That's kind of what I talked about there earlier. So I used to have just a few sort of fixed places that you could load blueprints from. Basis/blueprints was one, and game/blueprints was another one. Those are the two places where, you know, the engine and the base game loads its blueprints from. And then when I added mods, I was like, right, so okay, any folder that's called blueprints and has JSON documents in it, we can load those. But like I said previously, that's a little stupid and a little risky. So let's not have that. Let's instead just load any .blueprint file. And then, yeah, we need to skip, of course, the things that are in the load the fixed load order blueprints we have on disk. So it looks through these fixed loader ones and erasing the path from, you know, all of the ones if we have them. So we load them first, and then finally we load all of the rest, all of the ones that were still left in the list. That's how it works, and we're gonna have to change this up so that we actually load all the .blueprint files instead. Let's see how close are we to finishing. We're actually pretty close. So I'm gonna have a sip of water, and then we're gonna see what happens if we try to start the game with this. It's probably just gonna crash and complain that I can't find, you know, can't find engine blueprints.json. I think that's probably what's gonna happen. And the asset server will tell us, yes, work folder initialized, thank you. So now it's logging into the asset server. Oh, why is it actually doing that? That shouldn't be. Oh, we're running the wrong game here. That would be why. That's embarrassing. Yeah, you can have the same asset server serve multiple games. And so, yeah, I'm a little confusing as to how that actually works still. What? What? I probably just made some stupid mistake here by like clearing the cache of the wrong game or something. Let's see. No, the game is correct. Load blueprint on JSON. That's not the correct string. We need to look at the string here. Right, so it's still giving us JSON files. Trampoline app JSON. Okay. Huh. Yeah, that's the Flying Scout JSON. That would still be a JSON file. Exactly. Yes. Okay. Right. Okay, so it's just loading that one file that's found in the mod. Yeah, if you try to play the game though. Yeah, now we can see. Okay, so no registered game. We just type gameplay, campaign game master. It can't even find the game master because it can't find any of these JSON files. It's a little stupid though that it seems like it's just going through with them. It's just not loading anything. This is optimize off. Let's go have a look here at load blueprints. I think you should just, barf at this point and go like, ah, that's not good. Oh, you know what it actually is here. I know how this, how this works / doesn't work. We just push these to a list, and then we get all of the JSON documents. Yeah. Okay, I should have seen this. So we have a bunch of JSON documents still in the game. None of them are actually blueprints except for that one. For that one scout, which is the last one here. Yeah, these other ones are just like JSON files that have nothing to do with blueprints. What's this one? So in place buffer is 0, but the pointer is, yeah, it's long enough that it doesn't fit into 64 characters. Okay. Yeah, so that's how that works. That's fine. I don't really care. So now if we just if we replace this with just .blueprint, which is essentially what we want, we're probably going to get a different error, because the thing will go like, that's not a JSON document, because it doesn't know what a .blueprint file is. We're just telling it that, hey, this is a file that you can read as JSON. Oh, that's never gonna happen currently. Right. Okay. Yeah, we're gonna get the exact same thing. Anyway, this is progress. That's what we want. We don't want to do this though. So let's put a pin in all of this stuff. Just comment it out. And instead we're gonna do vector string blueprint resource paths. And we're gonna do basically the same thing we did here, but this is gonna be now this blueprint resource paths. This is going to be basis resource type. Where is it? The raw data file. So anything that doesn't fit into one of the known extensions becomes a data file. And maybe we can resurrect this for loop here and actually right, so we're checking here if it is a blueprint. And previously we needed to figure out, you know, which folder it is in and all of that, blah blah blah. We don't need that anymore. We can basically just do ends with and then dot blueprint, right? And so if it is not a blueprint, we just actually erase it from the list. Otherwise we accept it, right? Something like that. So that should give us all of the blueprint files. So maybe we can what should we do here? Do like a const string path in blueprint resource paths. And we can do basis print f path. Now we should get all of them. Not just the one, not just the fixed ones, all of them. Something like that. Right, I just want something to stop on here. So let's see what happens now. So now if we go and have a look at the output, here we go. So we got all of them except that one file in the mod, right? Because the mod is still a JSON file, so it just will be skipped. But that's fine. We'll fix it up later. So now that we have this, then we can get a we'll get that comment as well, like so. So load the fixed load order BPs we have on disk. That would be, you know, that, and then load all the other BPs. And then we have a function called load blueprints from JSON. So now we're gonna get not a JSON file in here, but a blueprint file. And now if we do this, we're gonna get that error that I was kind of thinking we would get earlier, right? Because now we're trying to open a blueprint file as a JSON resource, and the resource system goes like, what are you smoking, right? Resource type mismatch. That just means that you're trying to load something as something else. We're trying to load a raw data file as a JSON resource. Can't have that. Even though, you know, that it is byte for byte the exact same thing, we can't have that. So instead we need to load it as a raw data file. Like here, raw data file. I think it's actually just called raw data file, even though it should really technically be called raw data file resource. Yeah, there we go. Right. And so the thing is that we don't get a document like this out of the file, but we can just basically do it ourselves. So this is what the the entire JSON resource looks like. It's a pretty short class. When it's loaded, we get a temp buffer that we allocate. Yeah, there's a comment from me from some years ago. Just because it wants like a zero terminated string, we have to actually copy it into another buffer and then read it from there. because the resource is not zero terminated, which, you know, maybe it should be, and we could make it, but it isn't currently. And then out of that we create a document, a JSON document, and we parse it. And then we delete the temp buffer. So let's copy this thing. Let's copy it into here. So this then goes into the blueprint manager, which does the actual like figuring out of blueprint stuff. So blueprint resource, that's size in bytes. Resource file. All right, that's actual resource file. So what we want here is, let's have a look. I think this, yeah, it's just called get size, and then the data is get data. So this would be blueprint resource, get size, and we want +1 because we want the zero termination, and get data. That's actually true. And then we want to copy the size. So many places where we actually call this thing. Let's just copy that into size t. Data size is that, and then just use that instead. That's nicer, like so. And a rapid JSON document, I think we can just basically create like a doc here. Not need to do anything like that. Just do doc parse temp buffer, and then if document has parse error, we wanna let the user know. Resource path is that, and then we delete the temp buffer. That's fine. And now we can just give this to the blueprint manager, right? So we're essentially just like switching out the actual JSON loading for like a handwritten thing here. Let's make sure we clean up after ourselves. So the array is created here, and we delete it there. Resources, yeah, that's probably fine. So this is just like you're telling which memory pool we want to actually allocate that from. I guess that kind of makes sense. It would be a resource pool. And then the actual blueprint resource itself is released here. So the resources are reference counted. Right? Let's see if this works. Alright, Zig logo blueprint missing enum mesh component type in blueprint data. Yeah, Zig logo is a resource pack with just basically like one Zig logo, right? So Zig logo.blueprint. Oh. Yeah, you know what? You know what actually has probably happened here? We can see that this is a blueprint file that is not actually contained in a blueprints folder. So what this thing has actually exposed to us here is a blueprint file that actually has never been loaded, or hasn't been loaded for a very long time, right? Unless we actually load it ourselves by hand. That's possible. But yeah, that doesn't seem like we do. Actually do that. So this thing probably hasn't been loaded for some time, and the error we get is missing enum mesh component type, and this is like something that was added to the mesh components, you know, some time ago. So if we go have a look again here, I'm gonna make that a little smaller. Let's find a mesh resource here. Mesh component actually. The mesh component type is here, determined by transform. We need to basically add this here to the Zig logo blueprint. But I think we can also just open it up in the editor. Zig logo blueprint. You can see that, okay, yep, that looks good. and it has the type here. So if we save this guy, then you just come back here. Now it has magically gotten that mesh component type. So the editor, one way of just making sure that everything is sort of up to date is just to open and save things in the editor. And look at that, now it works again. So now if we go into a level, let's go into the same depot level we were in previously. Everything should work, but we should not have this. Oh, we have the flying scout here, but yeah, it says no registered game object type vehicles flying scout. And I think the reason for this is that the mod itself actually goes and adds this vehicles flying scout to the list here. But of course it counts on the actual game object type being registered. So now that it's not registered, we just assert fail. So let's go in and fix that now in the mod. And now we can get rid of that stupid folder that's there just to tell the system that this is a blueprint, right? So flying scout, let's copy that guy out of there and put it in the root of the resource. Get rid of the folder. So this is essentially what I wanted to have. So my workflow is currently such that if you have a folder called _work, you can put things into here, and the asset server doesn't try to actually do anything with these. You can just have them here if you want to have your work files. So you have your Scout Jetpack Blender file is right here. If Blender would open. It's kind of annoyingly slow to open Blender these days. I don't know what that is about. Here we go. So here's our mesh. Here's our texture. And then you can export from this Blender file out into, outside this work folder. So that's the FBX for the jetpack. We have some flame FBXs as well. And then we have the diffuse texture here. And you can see actually from this diffuse texture png.meta, this is a file that the texture converter creates automatically for you to store the meta information. And you can see here that these work PNGs here, these don't have any meta files because the converter is sort of actively ignoring these files because they're found inside of this work folder. All right. So now we need to actually build this, which we can do with this build data batch file, like so. And we can see that among other things, we are converting the blueprint. I showed you earlier that we have this JSON preprocessor that will run the blueprint files through, and it strips comments and minifies the data. That's almost exactly what I said it does. So it just gives you an error if you have like a syntax error in your JSON, basically. However, we still get this .json added here, and that's just because I forgot that I need to update the script for the mod as well. So the mods are considered their own completely sort of independent sort of work folders with their own conversion scripts. So let's just copy this blueprint operation from the main one and put it in here into the mod one as well. And so now we can again just kill the cache and we can build the thing. You can see now it's doing a whole lot more because we destroyed the cache there. So it's doing some mesh conversions and even running the texture converter here for the texture file. So that's fine. But most importantly, we now have what do we have? This one. Resource flying scout res / flying scout.blueprint added. So if eventually you want to build mods for the game, you're gonna be looking at something similar to this where you have a bunch of folders that are scored like under double underscore something, and these guys are things that you typically don't really, you know, want to touch all that much. They're sort of like part of the pipeline, data pipeline. Occasionally you want to do things like, you know, get rid of the cache, something like that. And then you have a batch file to build it, and then you have your actual resource pack. So this is a resource pack because it is found here in the root next to these special folders. So this will become a BP4 file. And here it is, that's the BP4 file. So that's cool. Now we just need to put that into the place where the game can actually find it, which is in app data. And of course this is something that like the in Steam, like Steamworks would take care of, things like that. So here we have the WASM module and we have the BP4 file. Let's just copy that thing over and copy exactly everything. Just put it there. Like so. And now the mod should work again. Let's make sure. So depot. Let's try to spawn a scout. Oh. That's not good. Am I just running the wrong version of the game, perhaps? Not necessarily, but I might be. Oh, I know what this is. Yeah, I know what this is. I shouldn't actually have I shouldn't have replaced that WASM module there. This is the thing that we fixed in the last stream. I just haven't actually submitted what I did there, apparently. So here if we go to build and have this, you know, put it directly in the app data folder, we can just do Zig build. And now we're actually building the code for the mod. So if you're making a mod, you can have it. Oh, what? Well, isn't that great? Let's see. No module name basis build options. Let's delete the cache, the Zig cache this time around. And then we will build a... yeah, we're building it as WASM. That should work, but it doesn't. No module name build options. What? It's right there. Basis build options. We can see that it's trying to do the trampoline part and it's failing, it would seem, from there. So does that mean that trampoline doesn't have... I think that's probably what it means. It's strange though. I think I would think that this is something that that, you know, the main game would run into as well. Let's see if the main game actually builds. And the main game, of course, does the same thing. So we have a basis module import. Yeah, the main game builds. Huh. And trampoline module. anyone from the Zig Discord who's smarter than me, tell me what I'm doing wrong here. Let's do one test. Let's make that build as WASM. That would be like build as WASM is false. Oh, it needs to be all in one, I think. Nope. Oh, we can just set it from here. Bye-bye. Yeah, we have the same thing here. If we're building as a native one, that makes sense at least. It's not like a WASM related thing. All right, it's probably, yeah, that would have been it, right? Zig build D build as WASM true. No? Okay. It should actually work. Wow. That's strange. Well, anyway, let's just go into every single little weirdness here. Just try to figure out why this fails. So we have the add modules. Add modules is added here. In basis module, we do an add import. So do we need to do the same thing just here for the trampoline module? Is that what we need to do? Yeah, I didn't really think we would have to do that either. Strange stuff. What about if we do the thing we actually did in the last stream and do like game mode is, I think it was means lib. But this is what we added that. The functionality we did in the last stream was basically to be able to do gameplay types, get game mode. Let's actually do get game mode by context and then just feed it the context like so. Oh, here we are actually doing it. Okay, I didn't have it removed. Yeah, this is exactly the thing we did. So let's get rid of that and see if that actually kind of fixes it. Yeah, it does not. Oh, that's strange. Do I have some crap here in my local repository? No, all the Zig code seems to be submitted. Wow, that's strange, isn't it? Why did I not run into this on Friday then? So let's take a look. It's complaining that no module named basis build modules available within module basis, even though we are adding it here. Basis build options. That's the build options module. The build options module comes from here. We create a build options module. And we add some options to it. Yeah, and then we create a module. That gives us a module. And then we pass it to, comes in there and it is added here. What's that about? Oh, Am I just being bad at my job once again? You know what? I am. And you all probably saw it immediately. I was just in the wrong folder. I don't know why VS Code had put me in the wrong folder. A wrong folder that just happened to have... whoops. A wrong folder that just happened to have a... like so. A build script as well. Which made it less than obvious to me that that's what actually was going on. Okay, never mind. With that little snafu out of the way, now we should be able to actually see that right, our blueprint is back in business. Depot and Flying Scout, and there's our Flying Scout. Cool, and we even get the game mode stuff that we added on Friday, so everything works. Everything works if you are in the correct folder when you're running your command. Yeah, it would be kind of obvious that you're in the wrong folder normally, because the thing would say like, yeah, no build script in current folder or something like that. But VS Code had put me in another folder that had a build script. So it's really trying its best to make me confused. Okay. Anyway, that's nice. So now, basically, what we can do after all of this craziness here is quite simply we can have blueprints anywhere on the file system, essentially, right? Anywhere in the data. No longer needs to be in a folder called blueprints, which is not allowed to have any other JSON files except blueprints. Now it follows the much more logical path of just having .blueprint files that contain blueprints. So that's nice. Much better. Okay, excellent. Let's go have a look in the editor quickly and see that I think that that Zig blueprint thingy should now be there as well, shouldn't it? Unless it's actually, yeah, it's not disabled. Let's have a look here. Do we have Zig logo? We do. Hello, Zig logo. Fancy of you to join us. Yeah. Okay. Yeah, so the Zig logo actually has been there for a while, but it just, you know, it has probably quietly just been removed from this list here, and I haven't realized it. So look at that. You find issues all of a sudden when you fix up things. Coolio. Okay. How nice is that? So I will have just like a whole bunch of things to actually submit after this. Fixes to one thing or another. Okay, so the next thing for us to do would be to rework the blueprint manager a little bit, so that we can do that overriding of things, right? Because now we're calling, this is the new code that we wrote, now we're calling load blueprint from JSON, and this guy does the new JSON reading that we did. We end up with this document here, which has the JSON data. And then we feed that to Blueprint Manager, load blueprints from JSON. So this is something that is done only once, or it's done a few times, but it's done only at the app startup time. That's why we keep them in JSON. It's actually remarkably fast to do still, but it's not really something, you don't want to parse JSON, you know, when the game is running. You just want to do it once at app startup time. And what it does is it looks through all of the blueprints that's found in the file, because there can be several, of course. And it does load single blueprint from JSON. And what then happens, especially with regard to the base types, is that if we go into the game object class, basis game object CPP, yeah, we can see that I've actually looked at this recently because we landed at the correct place. So there's this pretty large function here that actually like initializes a game object create. So from these parameters we get a type, which is just a string, and from the string we get a blueprint. Get blueprint from the blueprint manager. And this blueprint knows, among other things, if it has a base type. So yeah, we add an editor component. If we are in the editor, we can skip that. But then we look here. Do we have a do we have a blueprint? If not, we go into this sort of error mode here, which only really should happen in the editor. If we're not in the editor, then we just get an assert failure. But this is the important part. So add base type for the add base type components, and then after that we go in and we add all of the components. So basically we do a little bit of figuring out here when this blueprint is used. What is my base type? What are the components that are in my base type? And then it looks through and adds them. And I think even this thing probably calls itself, yeah. So if the base also has a base, right? If the base type has a base type, then we add those as well. And then we add all of the components. So I think to be able to do this, efficiently, we want to essentially flatten these blueprints completely at app startup. So the game object doesn't have to do any of the base type figuring out anymore. The game object can quite simply do this part here. It has a blueprint, which it gets from here, which is its type. And by the time it has come here, this blueprint contains all of the components that this component or object is supposed to add, right? So all of the base types, all of the grandparents and other ancestors, all of them are stored here in this blueprint, and you can just add them up. I think that makes sense because that also allows us to verify at app startup time. Okay, if we're overriding a component that is ostensibly found in a base type, if it's not actually found in the base type, we can just error out right there and then, rather than having to do all of those checks then later on. Right, so Abouden says, what are blueprints in your engine? Is it like a visual script lang on top of your regular scripting lang? No, it has nothing to do with visual scripting languages. I do have a visual scripting language. I have several actually, sort of semi-related things. So here's a script that runs the mission logic for the demo mission, which you can play today if you go to the Discord and download pre-alpha 2. You can play this, and you can see that this is actually kind of maybe visually inspired a little bit by Unreal blueprints. You have these execution pins that are these arrows, and then you have data pins that are round or square in some cases. And so this is a visual script. This has nothing to do with blueprints in my engine. Blueprints are really just a collection of components that together are associated under one name. So again, if we look at the vehicles, because I feel like this is a pretty sort of intuitive way to look at it, we can look at the Scout, for example. So here's the Scout blueprint. The Scout blueprint consists of a bunch of components, among them the chassis, and we can like turn the chassis mesh on and off like this. Now we can just see the interior. And this is the blueprint for the Scout, and it is, you know, found under this vehicles/Scout name. So then in the game or in the editor, you can just refer to this vehicle/Scout, and it knows, okay, this is the kind of object that we want to create based on that blueprint. So that's what a blueprint is in my engine. Yes, it has nothing to do with Unreal Engine blueprints. It has nothing to do with scripting. It's a group of components and their associated data. And yeah, it's been called blueprints in my engine for a very long time. I'm kind of annoyed at Unreal Engine blueprints because I feel like to some extent my definition of blueprints is actually more logical than their blueprint. Like I don't have a problem with Unreal blueprints. It looks like a very cool system. But I feel like the name blueprints is much more applicable here, because you have a blueprint which is like how to build an object of a certain type, and this is the recipe sort of, and then you put that together. While like their blueprints are more like visual scripts, which I guess can be blueprints for certain things, but more often than not, you just you chuck them onto objects. They're not really a base for anything. They are the actual thing. If that makes sense. So yeah, that's my little rant. So yeah, we need to flatten these blueprints down, and we need to do it. I don't exactly know how we want to do it. How we best do it. But I think that since we essentially Alright everyone, welcome back if you are still with us. So it kinda looks like having some hardware issues here. Kinda looks like my ISP just had like a major outage. And it just brought all the internets down at the same time. So I apologize for that. I even have like a, yeah, we can get that visual there out of the way. I even have a backup. Well, it's not really a backup. I even have a second internet connection here, but annoyingly it's like the same operator. I should really have a different operator, but or ISP. But even that didn't save me this time around, because it looked like the whole ISP was somehow hit with something. Roski's got a NetC cables again. Yeah, who knows? Something like that, maybe. Anyway, we are back. For some reason, the chat doesn't actually seem to refresh now. That's a bit strange. Let's see if we can get the chat back up again. I mean, the chat in YouTube works, but the chat in the stream seems to have somehow frozen. Refresh cache of current page. There we go. Okay. That's what I needed to do, apparently. I'm learning things here as I go. Anyway, with that out of the way, I was able to go get a little bit of coffee during the outage, and so that is probably going to help me write much better code. So maybe it was for the better. Anyway, yes. Like I said before the break, what we're gonna have to do here is, quite simply, something like this. Right? When we have loaded all of the blueprints into the blueprint manager, we're gonna have to create a new thing, which is called something like flattened blueprints. And flattened blueprints will basically look at like, where's Milton? Let's get Milton here. Here's some earlier stuff. I don't have my drawing tablet here. My daughter actually has it currently. So I'm gonna have to draw with the mouse. I apologize for that. So currently we have like I'm sort of specking this out for myself as well. You know, we have a BP blueprint, and the blueprint has some sort of base, right? Some sort of base blueprint, perhaps, and the base blueprint might even have, you know, another base blueprint base like this, and these all have their lists of components, right? That one has 3 components, this one has 2, and this one maybe has just 1. So, you know, what flattening this means is that at the end of the day, this guy will have all of those. So we add these 2 to the, actually the first thing we do is we add this one. We add this one to the list, so that's 1. And that's an arrow. And then we add these 2. So those 2, and then we add all of these. So that would be 3 more. Right? And of course, we can do it in such a way that, like, first we look at this. It doesn't have anything. It doesn't have a base, so it just has its own list. Then we look at this thing. This thing has a base, and so it basically gets this guy appended onto its own list. So it has 3, and then for this thing, the only thing we need to do is add this guy onto the front. So it will be essentially these 3, and then it will end up with 6 blueprints, right? So then when we actually instantiate one of these blueprints, we can just use this blueprint because it has all of the components. But importantly here, what this allows us to do is we can look at everything that goes on in here, and we can see it like, okay, this is one of those overwriting components, right? So, and it has some name, and let's say this is the same thing with the same name. So then this thing can like replace that, and then this thing actually essentially gets removed. Let's add a red one here. That's a pink. That's a pink color. So that one becomes removed, and it gets added here instead. And then we get, you know, the three components plus just the 2, which is like this one and that one. And then all of these 3 are like those 3. Something like that. Something like that. Yeah. I think that should basically do it. I think actually now that I think about this, I think this thing should, every time for every blueprint that it flattens, it should flatten all the way up to the top. I was just saying that we can just flatten this base and then we can flatten this blueprint, but we don't know in which order these guys are gonna come in. They can come in any crazy order. And the only important thing here to keep in mind is that when we call the flattening, which is this thing, flatten BPs. The only thing that we need to keep in mind here is all of the blueprints need to be there, but we don't need to care about their order. Their order is undefined, essentially. Right? Yeah. I think that should be fine. So let's go do that. Let's see what we have. I think I'm just gonna quite simply add that function to the manager. So load blueprints. I'll just be void flatten blueprints and add it here. Burp. And then we can see, do we have the blueprint manager actually like included here? Apparently not. So let's get that done as well. And it sits in, where is it? Is it actually just blueprints? Blueprint manager is where? Game object. Okay. We don't seem to really use any other game object things anywhere, so let's just include it in a suitable place. Game object. Oh, game object blueprint manager. Like so. And now this thing should momentarily go away. There it went. So this now becomes important to do because if we if we remove the code that goes in and loads all the base objects from the game object, which I spoke about before the break. Like we remove this line here. Then it's important that we do the flattening, and we do the flattening in all of the game projects that I have going. So I just need to remember to add that flattening to those other ones as well. But that's fine. That's for me to figure out when I review this code. Because I kind of do like code reviewing among myself. Like I worked at several companies who have done like formal code reviews, and I still do actually. And I know the power of them. So if I have like a really huge system that I've done, and I'm not in a super hurry to actually submit it, usually what I do is like I wait until the next day, and then with fresh eyes I just go through that code. And usually I find like an issue or two somewhere. I think this is probably going to be one of those things. So tomorrow morning I'm going to go through what I did today, and then unless I find some really bad issues, that is when I can actually sort of like start working with this properly. Okay, flatten blueprints. So what do we do here? We have a list. Let's get actually let's close all but this, and then open the header here, right next to it. So what do we have? We have just a vector of blueprints. And a blueprint is really just some information here, and then a vector of components, right? So what we want to do, before we get to any sort of overwriting, I'm gonna want to do the flattening here, because that is probably going to be not necessarily the trickier part, but I'm thinking like it's the part with the most actual work. So let's not care about any of the new sort of overwriting values yet. We don't necessarily have to care about the JSON reading at all yet. But instead just look at this and go, okay, so we have a blueprint, it has a base type potentially. If it doesn't have a base type, then just, you know, early out immediately. If it has a base type, then go into that base type and figure out if it has a base type, and so on. And while we're doing all of this, we are just collecting these components into a list. And you can only overwrite components that have been encountered previously in this list. So we don't need to do any sort of super crazy like forward and backward looking through the list to figure out what we need to overwrite. If we encounter an object or a component that is set to overwrite the previous one, that previous one should appear before that in the list. If it doesn't, then that's just a straight up error, right? So I'm thinking we'll do void flatten blueprint without the S, and we'll do probably just blueprint blueprint reference like that, right? And then we can go down here and add this here, and that's like this is the logic that will be run for each blueprint. So for blueprint BP in blueprints flatten blueprint BP. That's the main loop. Here we want to have probably another function which we can call iteratively. or no, sorry, recursively is what I'm trying to say here. So resolve base type components for a blueprint, and we'll want to have a vector of and this is now important. This is going to be, oh, by the way, just mind jumping from one thing to another. I'm gonna want to do pragma once now that I'm poking at this guy. Let's go to blueprint and do the same thing here actually. Pragma once. And this guy has a blueprint component, right? We already include the blueprint data here, so that should be fine. So blueprint component, that's also supposed to be a reference. So we give it a list of components, and that list is the list that we will sort of collect all components for this particular blueprint into. Okay, so when we flatten the blueprint, we do vector blueprint component, what do we call that? Flattened components, right? Something like that. And then we call this resolve base type components with the blueprint and the list. Hey Matt, welcome back. Today we are first of all experiencing internet connectivity issues. So yeah, we had a pretty good thing going, and then all of a sudden the internet cut out. Seems to be some issues with my ISP today, so let's hope it doesn't happen again. But we are we're improving the blueprint system so that among other things, in the future, mods can just outright replace components on other things. So previously, you've been able to base a game object type on another game object type by setting like the base name in the blueprint for that game object type. But you've only ever really been able to add things to, like, on top of the base type, right? And with this system now, we should be able to just completely remove or replace components in the base type. So if you wanna do a new, new scout that has a different mesh. Previously, you've only been able to add new meshes and things like that. That's what the flying scout does. But if you want to completely replace the mesh with another one, you should be able to do that here. And as part of that, I've just looked at this blueprint system overall and actually found some bugs during the stream. So hardening as well, essentially. And what I'm doing now is I'm essentially, like, up front, I'm flattening all of the blueprints so that if you have a type and that type has a base type, then it will collect all of the components of itself and its parent and its parent's parent and so on into just a single list. And this is at the point where I'm thinking about doing that replacement, right? So it should be good because we've been sort of resolving these relationships between, like, base types and actual types at runtime. Like when you actually create a game object, that is when it's been done. So I'm just doing it all up front now. It should be more efficient this way. But let's see. First of all, I think we should probably just make it so that if this blueprint base type is empty, then we continue, right? We don't need to do anything if it doesn't have a base type. or well, we kind of do if we want to do like replacement within the blueprint. But I mean, is someone gonna do that? Is that something that anyone is ever gonna want to do? You know, if you have a blueprint like this, just open anything here and just add like a name here. You know, someone adds a mesh here. Oh, but they can't do that actually. No, they can't actually replace. Yeah, because I was thinking that the replacement would happen based on the mesh, right? So if we add another mesh here, and then we want to call that mesh as well, the thing will go like, that's like that. You can't do that. That's stupid. It has to be called mesh 2. But you know, you could do this in theory. You could do this and then, you know, take the 2 away. Like, is anyone ever gonna want to do this sort of thing? You have a mesh here, and then you immediately replace and overwrite this mesh with this mesh. Probably not. Yeah, I don't know. We'll have to see. We'll have to see. I think I'm gonna probably do the overwriting anyway, like in a separate pass. Let's just do the flattening here, and that will figure out if we need to support that sort of thing. I mean, it could actually be handy. I'm thinking about some development scenarios where you have like, you know, like a really long blueprint, and then you want to just like, for testing purposes, you want to actually like switch out a component for another one. Yeah, that could actually be really useful. We'll see. Talk is cheap, write some code. Oh man. You know, you shouldn't write code if you don't know what you're gonna write, right? Right. If you just head into the thing you're trying to make without thinking it through, you're just gonna end up with something that you don't want. Yeah, these are important decisions. Thinking is for the weak, yes. Absolutely. Yeah, thinking is for newbies. Right. So we've gotten here. We have a component. We have a list of components. We want to collect all the components to. And essentially at this point we know that we do have a base type because we early outed there. So let's do this could probably be a const, so we don't actually accidentally start poking at that one, right? Get blueprint by base type. Oh, I need a non-const version of that, don't I? Yeah, I need a non-const version of this, and that actually gives us a pointer. Okay. Mm-hmm. Mm-hmm. Yeah, let's do it like this. Blueprint mutable. I'm gonna make that private. I'm thinking I'll actually just want to have, because this thing is not supposed to be used from the outside ever. So it will be like this, and then like this. And then here we're just gonna assert actually that actually maybe it can be a assert F, and then we can do what's that? Qualifiers dropped. Yeah, okay. Fair enough. Invalid blueprint. Yeah, just like that, and then we do game object type name, like so. So here we just want like so, and then that should work. Oh, it should be called mutable. Not that we really want to mutate it here, but I mean, we're gonna mutate that one anyway, so this thing needs to be you know, non-const, which means that we can't call that which is const. Something like that. Right, and then from this, if this thing has a base type, so if the base type is not empty, we're gonna do resolve base type components, right? So we haven't added anything to this yet. I'm just thinking this through. We haven't added anything to this yet. We come in here, we get the base type. We immediately check if that has a base type, because, like we figured here, we want like this ancestor to appear first in the list, right? So now we can do components dot, actually, for this can probably be a const. Blueprint component C in vp dot components pushback C, and yeah, it could be emplace back. But no, it's gonna be pushback. That's it. I think that would do the flattening, right? That would do the flattening for us. Let's add a basis. Whoa. What's happening? Basis optimize off up there, and we'll do. Yeah, again, I'll just do like an int I something, so that we can stop on that. Since we have the optimize off, we can run it even in. Oh no. Let's go out of full screen mode here and just compile this. I have a feeling we're missing some include or something. Yeah, cancel. No. What? Really? Let's have a look at this. What do we have? Class redefinition. Oh no. That's why. That's why. Bro doesn't even code in Scratch. I have no idea what any of that means. Let me be completely honest with you here. What is Scratch in this case? You're talking about the beginner-friendly visual programming thing. Is that the Scratch? Or is this some newfangled AI thingy that I don't know and I don't want to know about? Do enlighten me. And if you're talking about the beginner-friendly visual programming thingy, then yeah, I regularly code in Scratch together with my kids. It's a pretty fun thing. It's fun. It's fun. Okay. Let's see what happens. So, flattened components now then. Right, we only have one. What? Tag flag component. Tag flag component shouldn't really have any base though, right? Or does it? I don't think it does. Maybe it does actually. Let's see. So this is the physics game blocker. Yeah, I have a feeling the debugger is yanking my chain here. There's actually a physics blocker and the baseline is a blocker. Good. So it has nothing to do with the tag flag. Cool. Right. Let's not step into that monstrosity. Protecting the kids from the C compiler errors. Yeah, I mean, I'm not protecting them. I'm just kind of like, if they would have to deal with C compiler errors, I'm pretty sure they would just just give up and go like, hell no. Okay, right. So the game blocker actually has a tag flag component. That's fine, and it derives from physics blocker. Physics blocker does have like 3 components though. So why do we get only one? Or is it just like, okay, I'm right. Let's do that again. Let's do that again. I think actually, that's probably fine. Let's keep it here. Yeah, so that has just one. And the BP is the game blocker. So something went wrong here actually. Let's step into that one more time. So this would be the game blocker, and this would then be just physics blocker. Yes, physics blocker doesn't have anything, so that's good. Components. Oh, right. That's the problem. We want base BP there, right? This adds the base components. And then we still need, we still want to add the actual BP components to the list. And it's called flattened components here. Maybe we should call it flattened components everywhere. Yeah, it's giving me a warning for that one. I mean, sure. We should probably return something. I think Clang is at least going to be angry with us if we don't do that, so we should just return something. But this thing is important. Yeah, now we don't get any warnings. Alright, so now if we go down to this I, we should have 4, right? Here, yes, now we have 4. So we have transform, physics blocker, editor icon, and then the tag flag comes as a bonus from the current one. Good. So that's the flattening essentially done. Gonna have to test it some more, but I think the logic is solid there. So now then, now we have a list of flattened blueprints. Actually, I think I want this guy to be given to us here, right? Flattened components. And we can essentially, like, we can take that away and maybe move the check into here. So if BP base type is not empty, then we do this, right? So flattening also works if you don't have a base type. It's just kind of, you know, pointless in a way to do it. But still, it does work, and that allows us to do the replacement or overwriting, whatever you want to call it. Overwriting is, I guess, technically the correct term here. You can do the overwriting the same way for components that exist in the base types, as well as components that exist in the actual blueprint. Cool. So now then, now we want to reverse iterate through this thing. I think. And we want to reverse iterate in... Yeah, we want to reverse iterate because components appearing later on in the list are higher up in the hierarchy, or further down in the hierarchy, depending on which way you look at it. And they should always overwrite components that have appeared before that, right? So I don't usually use this, but there's something called rbegin, isn't there? rbegin. And rend. And the thing is that if we iterate over the items in reverse in the list, and we determine that, okay, this one component is actually trying to overwrite a previous component, then we should essentially remove it from the list. We should get a copy of it essentially, and then remove it from the list, and we should just assign it to a component that came before that has the same name. That's essentially what we want to do. So let's take this here, and we do flattened commands, flattened components. Why is it complaining? Too many arguments in function call. What? All right. I need to add it here as well, of course. I've been writing so much Zig lately that I don't remember that. Oh, we actually have this thing called a header. This fancy language of ours. So, you know, somehow we determine overwriting previous component. We can set that to false for now, because we haven't actually read that from the JSON data yet. But if we are overwriting, then we actually do an it flattened components remove, right? Else we do ++it here. No, that's actually called erase, isn't it? What? Does erase not work with reverse iterators? Oh. Is there like an R erase? No. Oh no. What do we do about this? What do we do about this? C++ experts help me. Let's see. reverse iterator and erase. Let's have a look here. Yeah. Basically what we could do here is we wouldn't even really have to necessarily we wouldn't even really have to necessarily use an R iterator. Yeah, okay. You can do it like this. But this is just freaking retarded. If I use this, I would have to link to this thing, because like in 2 years when I come back and look at it and go like, what the F is this? C++, ladies and gentlemen. Let's not use a reverse iterator. Let's actually just use indices, right? Because if we're removing from a list and we're using indices, then that should be fine. We should be able to remove stuff and then just go towards the front of the list as we are doing it, right? That should be completely fine. So what we need to do here is first of all, recognize that the standard iteration, if we have an unsigned integer, is going to crash our program if we try to use it and go like, it needs to be, you know, larger than or equal to 0, because an unsigned integer will never go below 0. So what I typically do is I just, for shits and giggles, I just convert it into an integer, the signed integer, right? It's just easiest. So we do flattened components, size, and then we can do for I equals size minus 1. Oh, int I, size minus 1. I must be larger than or equal to 0, minus I. And what we can do basically is the same thing, where we actually don't do that here, right? No, actually, if we, I think we need to always decrement it, right? Even if we remove something, we then need to go step one back. Yes, that's true. Never mind. Right? So, if we're overwriting a previous component, then we need to figure out, okay, what is the name of the component that we want to actually find? So this would be something like name is flattened components, I, name, right? And the question is here, okay, should we continue iterating from where the overwriting component is towards the front? Or should we do it from the back? So if we have our components here, like this, we have some components, like this, and then we say that this is the overwriting one. This is the one that has the OBR flag set. And this is called, you know, A, since we're going with names here. If we're coming from over here and we're going in this direction, then we encounter this A guy here, this one. And what should this actually now replace? Because what if we have an A here and we have an A here? Should it replace both of them? I think it probably should. Actually, I don't think this should be allowed. It's possible that it is currently allowed, but I don't think it should be allowed. No, it is actually allowed, yes, because what if this is a base class? And then that's a base class. No, it's not a base class, but a base type. And then we have that one is also... This is the actual type. This is the base type. That's a base type. And this is just the type. Then it is entirely possible that this base type has an overwrite. This is also an OVR. OVR for that one. And now we are overwriting here. What the hell should happen here? I have no idea, actually. Like my knee-jerk reaction would actually be to, if we encounter an OVR for the component A here, we would actually jump all the way to the front and start iterating over here and finding all the A's as we go. Because if you are stupid enough to set yourself up for this this kind of situation where you have like overrides on top of overrides, it's gonna be, even if this works perfectly and is like properly spec'd and everything, it is just going to be super confusing for everyone involved. So I'm thinking that's actually probably what I'll do here. I'll just jump to the beginning and iterate until we come back to our OBR guy over here, and just like copy this guy to that slot and then copy it to that slot until we come here, and this is where we stop. Like that. Let's do that. Let's do that. That should probably be good. So we are at index I. J is to be smaller than I plus J, right? I can write a comment here to like look through the head of the list up until the current overwrite source, replacing components with the same name as we go. Something like that. I'm not sure this is the most efficient way to do this, but this is, you know, when I look at this in a year from now, it'll only take me like a minute to figure out what is happening here. So that's kind of why I like it. So flatten components, if flatten components J name equals flatten components I dot name, then flatten components J equals flatten components I, right? And I don't think we'll even, well, you know, if we haven't replaced anything here, maybe we should actually assert that we did replace. So bool did overwrite false. something like this, and then after this just do yeah, an F is probably fine. Did overwrite. Yeah, actually I put the name there in a nicer shorthand, something like this, right? So no component overwrite targets for component with name in blueprint. I think we have the blueprint here, don't we? Yes, we do. In blueprint that one. That's how it's supposed to be. PP name. No, what? As a name. Oh, there's a type. Right. Type. What type? C string. There we go. That's how it's supposed to be. Yeah, something like that. And then what we want to do is we want to, at the end, remove this very component from the flattened components, right? So we want to do erase, and we want to erase from the beginning plus I. There we go. And we don't need this else clause for anything. Right? Right? Isn't that what we want? Let's look through this. Have a little coffee. So we flatten the blueprints, and that gives us basically like this list. This flat list of all the types and the ancestors. We make that sign so we can do this. So we start at size -1. We need to be non-negative, and we go from the tail to the head. We still need to figure out this thing somehow, but that's fine. If it is to be overwritten, we get the name. The eyes are that's the source, and we iterate from the beginning to, but not including I. Yes, that's good. And if the target's name is the same as the source name, then the target is the source. Yep. I think that should be good. And then we erase this. And we can erase this, and it's not going to break anything because we're iterating backwards. So we don't need to do anything fancy with index adjustments after that. Yeah, that looks good. So the only thing we need to really figure out is this thing then. Overwriting previous component. And I think we should probably just actually add one of these guys so that we can actually test it out quickly, right? So let's do a gripper truck, or maybe we'll just do a scout. Let's do a scout. Yeah, I can copy the name, then I can make a new one here. So let's do vehicles. I'll just call it Scout 2. I don't have a... Oh. Please don't do that, thank you. So Scout 2 is based on Scout 1. We don't have a transform separately from this because we already have it in the base type. And what we want to replace is just the chassis. So chassis mesh like this, and we just replace it with something else, something stupid. Something stupid. So mesh component, yeah, okay. It suggests the name mesh there, but we want to have it as chassis mesh. Now luckily, one might say, I haven't actually previously made any checks for name clashes, you know, against base types. Because like if we try to add another one here now, you know, another mesh component, and we call this chassis mesh, it goes like, you can't use that already, the name is already in use. Well, the point here is that this should be fine as long as we set this to overwrite, right? OVR, and then we set the mesh to something stupid. Let's just make it like a cog and block out material, brick, whatever, something like that. And we'll make it like 2 by 2 by 2, and that's that. And so now if we run this, first of all, we should be able to spawn one of these guys, but we can add that to the spawning list, if I remember how to do that. It shouldn't be super tricky. I think it's actually set here. Yeah, here we go. So let's do basis, debug overlay, add debug spawnable object type, just add the scout there, and its distance from surface seems to be 2, so let's use the same here. So now that we're not setting this properly, what should happen is that we should have a scout which also has the cog, right? The cog should sort of be probably intersecting with the chassis. And what we want to accomplish here is have it so that since this is set to overwrite, it should just not have the chassis. I'm sort of thinking at the same time here, what should actually happen if we don't have this OVR here? I think we shouldn't be allowed to create another chassis mesh, but I don't know if I've ever actually tried that. So let's see what happens. I have no idea. So maybe just like plane and car. Yeah, I don't have a vehicle here for me, do I? Scout. Here we go. So, scout number 2. There is already a component named chassis mesh. Look at this. Okay, so we're handling it essentially. The runtime goes like, what? That's not possible. The runtime is smart like that. But if we copy this to the clipboard and then we paste it into Sublime, for example, to here, we can see that, okay, we have a, what? That's not good, is it? We're missing some stuff here. Are we not? I think we are. Vehicle Scout 2. Kind of looks like we might have to do a little bit of tool debugging anyway, even though I was hoping we wouldn't have to do that. Yeah, we're missing some of these just very base things here. Like for a little bit of context, if you weren't here from the very beginning, I've just been hacking on this editor for the past 24 hours or so. And so what actually happens here is, let's go have a look at the diff. Okay, actually it does look completely fine here. It's vehicle scout. Okay, maybe I just don't remember how that copying thing works. It's basically what we got when we copied it. We got like this part. Yeah, I think that's actually probably what it was. But anyway, we can see it here now as well. Can I make this larger? I don't think I can. Yeah, I don't think I can. But basically, we got a vehicle scout number 2. That's fine. Its base is vehicle scout. That's also fine. The interesting here is this OVR preb, overwrite previous, is set to true. And this is the thing that we want to read and set that boolean by. Okay, good. No tools debugging today. I'm kind of fed up with that right now, so happy to not have to do that. Load single blueprint JSON. Load single blueprint from JSON, and it goes down into here. And this is a very sort of by hand written by hand JSON parsing thingy. And yeah, we even have some binary serialization here, but I don't think that's used for anything. We should still probably add it there though. So let's do bool OVR preb. OVR preb. So OVR preb should be false by default. And we can just take one of these other boolean ones here and mess with it here. OVR needs to be a boolean. Yeah. This is really old code. I haven't touched this in literally probably like 5 years or something. It's really old code. So I don't wanna do anything to like clean this up right now because it works really well. So if we have OVR preb or preb get the value, if the value is not a bool, do an error message. Otherwise we read it and we store it there. That's it. That should be everything we need to do. And now we can go here and we can just quite simply do oh. No. No, we can't. Can't actually. I'm sorry. It's not the blueprint that has this value. It's not the blueprint that has this value, it's the component that has the value. So it doesn't go here, it goes here, right? After the creation policy. That's where it goes. Yep. That's better. So this one goes away. And the component just has a very similar sort of thing. So add that there. And then we do yank that out of there. And we add it after the creation policy, which is somewhere here. Name, type. Oh, there's the creation policy. Just add it here. So blueprint component data is that thing, and that's supposed to be return false. Oh, return false. Right. So blueprint component name error OVR preb is not a boolean. Right. And of course we don't need to have it because it's been added just recently. So blueprints without any sort of OVR preb value at all, they just default to false. All right. Yeah, we can add it here. I don't think I use these for anything, but it feels nasty to like have them here and not have them actually do the correct thing. Like so. Okay, so now we should be able to go back here and put in this missing piece. So this would be flattened components, I, OVR, Prev, and we can just take that away. Right? And so even if we're overwriting something that like doesn't exist, then it just goes away, which I think is a pretty sensible thing to do. If you add a component with a name and there's no like target for that, it just like goes away. It just doesn't do anything. That's probably fine. Alright, no component overwrite targets for component chassis mesh. Should probably just be target, right? Right, that's strange though, because this is chassis mesh and the Scout has chassis mesh as well. Doesn't not? Chassis mesh right there. Okay. So let's debug this then. I already have this optimized off here, so we should just be able to go Scout number 2, you know, if pp dot type equals that, then, you know, int I equals 3, breakpoint there, a manual conditional breakpoint. Right, so flatten components, let's have a look here and watch. What do we have? We have chassis mesh, we also have chassis mesh. That looks good, okay. So if we go in here, it's 21, so it's the last one. That's completely fine. The name is chassis mesh. Essentially, what you want to look at this is this M pointer. In place buffer can be something else, but in this case they are the same. So the chassis mesh is, which one is it? It's number 6, index 6. Where are we here? We're at 3, 4, 5. Oh, I did it already, didn't I? Okay. Start that again. Yeah, so now it is at 6, and yes, now we do indeed go here. So flattened component here, if we look at the, I should really have like this here as well, like so, and then we have the target, or the source is there, and their properties should be different. So the mesh resource path is Scout chassis for the target, and it is cog for the source. Excellent. So that looks good. So now if we go here, Now we should go up here and have a look at chassis mesh. This should now have the cog, right? Properties. It has the cog, good. We haven't erased anything yet, but now we have. So now we have 21. Good. And it's just running through the entire thing. Let's step out of this guy. No component override targeting component. I wonder why that fires. Now all of a sudden. Oh, now I know. Now I know why it fires. Right, okay. Okay, so what we need to do here is, after we've set this, we need to set the override prep to false for that one. Otherwise, you know, it iterates backwards through the thing, starts here and then, you know, arrives here at the target, and then it iterates this way from right to left, and then at this point it will again go like, oh, okay, this is an overwriting component, so we need to mark it as not being overwriting. Right. The target should have its OVR preb flag reset so that it doesn't try to do any overwriting of itself, since all of the overwriting for this particular source should have taken place already, something like that, right? So it's just a harmless assert failure here, but of course we should never even go into this if statement here, just completely unnecessary. Maybe we can make it so that we go directly into that level. Let's go, plane and car. Boom. Let's do crane development. I think that has a slightly more sane setup here. Yeah, not end up underground here in this level. So, scout number 2. There's already a component named chassis mesh. Huh. Okay, so what do we actually end up with after that thing? I was going to want to make sure that we do get, you know, the... Actually, I want to be like here. After the thing has taken place, we should only have one single chassis mesh, because we do the erase. Ah, now I know what the problem is. Now I know what the problem is here. Stupid me. Stupid me. So the BP here, it needs to be actually assigned those components. Components is flattened components. Right. That's the missing piece here. We've just collected those into this list. We haven't actually, you know, assigned them here. That's good. And now, since we do this, we need to go into game object and remove add base type components. This one needs to go. Bye-bye. We can't have it there anymore, otherwise it's gonna try to first add the entire flattened list, and then it's gonna go and, oh, okay, I need to add the base types, and we're gonna get duplicate components and everything. It's gonna be horrible. All right, so nothing broke yet, at least. That's good. Can we add one of these scouts? Look at that. Look at our beautiful scout. Look at our beautiful scout. If you're wondering what a beautiful scout looks like, it's this. that's really cool. I like this system for a few reasons. First of all, mods can now do this, right? You can, without having to know like a whole lot about, let's say, the mother vehicle. If you know that it has a mesh with a given name, you can just take that mesh and replace it with something else. I've also been thinking about adding sort of an empty component, which is kind of just like a tag in the data, which it can also be used to do overwriting, right? Or it can essentially only be used to do overwriting. So you're overwriting a component with nothing, which essentially means removing it completely. So that's fine. However, you can't really break the core game types. You need to still, you know, make this into a new type. So you can't, the mods can't just like completely break the game, but they can add new types that behave like the main game types, except you can just add and remove stuff to and from them. So that's cool. Very nice. I'm sure we have some like edge cases there that aren't handled particularly well. But since I don't actually exactly know what kind of, you know, edge cases I should even allow, I'm not sure I can even realistically fix them today. You know, assuming there are some, of course. Yeah, you can see that the collision shapes don't actually change with this, so the cog doesn't actually have any collisions of its own. So the collisions are those red lines there. Are the collisions, and then the white one, which is kind of weird and slanted, that's physics' way of weirdly showing the mass frame for the object. I never really understood why it kind of slants it. It has to do with the inertia of the object, how it's rotated. You can see it's basically rotated on all of these things because the center of mass is moved and their inertia might be a little strange because, or not strange, it's actually exactly what it should be, but it's not uniform, and that makes the boxes get rotated, look weird. Boink. So that's cool. And of course we can probably even replace, like now we replaced a mesh with another mesh. We should be able to just, oh, what's this? What is this? Yeah, we have a crash in the blueprint properties. So I'm assuming it has something to do with editor icon component. Shouldn't even be any editor icons in the game. It's probably something that we've done, right? See if we can figure this one out. Is this reproducible, first of all? If I shut down the game now, yeah. Okay. That's interesting. Blueprint component. Well, blueprint, first of all. Physics blocker. Oh. Oh, that's interesting. Yeah. This is exactly what would happen. So basically, the blueprint, or the blueprint component rather, has or can have a pointer to a blueprint properties object that it owns. And so when it dies, when we clear the blueprint manager, it's not like in a constructor or anything like that, but like when we clear the blueprint manager, which only happens at shutdown, we go and have a look. Okay, have we actually do we have blueprint properties for this component basically? And if we do, then we go and delete them. I think this is just, yeah, it's just a delete. But now, since we actually copy those components around during the flattening, anything that has a base type and blueprint components will have two of those. They will each have their own copy to, like, pointer to this memory, and they will both try to delete it. So we get a double deletion. That's what's happening here. Sorry, I'm stuttering a little bit because I'm already figuring out how to fix this. So the way I'm probably going to fix this is blueprint component. I think rather than having this be a boolean, what we will have is an enum, and the enum will have three states. So it will have just a normal state, and it will have, oh no, actually no, this has nothing to do with overwriting, this has to do with flattening. Yeah, okay, so let's do it like this. Blueprint properties, let's say that we have a boolean here, owns properties memory, right? It should actually be pretty easy to fix. So basically we need to tag this component when it is created, that whether or not it owns the memory to the blueprint properties. By default it will, right? So properties may be null, but this may still be, you know, actually maybe let's make it false. Let's make it false. Yeah. And then when we actually create that, so there's some place here where we actually assign that, right? It's not here actually. Where is it? Load blueprints from JSON, load single blueprint from JSON. It goes in here. And then here is probably where it does the properties business. Isn't it? Properties. Yeah, here we go. Okay, here. Have the game object component factory create a blueprint properties object to see if it needs one. And basically, if we have one, then we know that, okay, this component, you know, needed one. And so here, what we will do is owns properties memory true. This is the one that actually created the properties. This is the one that gets to destroy it, right? And here, when we do the flattening, we need to figure out this, if this component came from a base class, in which case it will not own the memory. or if it indeed came just from the normal one. Right, so here, flatten components, resolve base type components. Let's take this from the very beginning again, because this is getting so complicated that I need to kind of make sure I don't lose the track of this. So flatten blueprints is called on all the blueprints. And we call flatten blueprint, and this is still just the regular, well, not like a base class or anything, just the regular blueprint. So all the components that come from this blueprint get pushed to the flatten component. If they have any properties, then they should own their memory, right? So if c.properties, then we want to assert, this is just to make sure I don't get this incorrectly, owns properties memory. A BP component needs to own its properties memory. Something like that. Those can never be false. But then we go here. We get the base BP. We do resolve for that as well, which falls in here. But this is the important part. When we take the components from the base class and we add them to the flattened component, basically what we want to do is comp, I don't know, C and comp cannot own, oh, false, like so, and then we push comp here, right? When we flatten the blueprint and take all of the components from all base types, we need to mark the components as not owning their properties memory, since otherwise we, or something like this, otherwise we get double deletions, since the base types will also be deleting their properties. I can't type today. Properties. And again, you know, just so that I realize what is happening here when I look at this in 2 years' time, I'm like, what? Why am I setting that? That's weird. No, I know myself well enough to know when something is going to confuse me down the line and I need to like spell it out. All right, so let's have a look-see here. I can put down a few of these scouted dudes. I can shut down the game. Okay, we still get some. Right, okay, and now of course the thing that we need to still do here is if component owns the memory. Then and only then do we actually delete it. Yeah, this is something that I didn't think about at all with this. I didn't spend a single millisecond thinking about that, but now it's fixed. Cool. Yeah, because there will only ever be one instance of those properties, even if you are basing types of other types. That sort of thing. Okay, this is cool. This is basically what I wanted to do in this stream. Let's just, for fun, let's replace another one of the Scout's components with like a mesh. So basically, like currently we replaced one chassis mesh with another chassis mesh, even though it's just a big cog. We should just be able to replace, like if we're gonna replace like the dynamic body transform, it's just gonna, everything's gonna break. So let's not do that. But we should, for example, we should be able to replace the vehicle renderer. Like I don't have that component that I spoke about earlier, which would be like, an empty component, so we can just like take something out. I don't have that yet, but I think I'm gonna probably do that like later today or tomorrow or something like that. But in the meantime, let's just add another component here, and we add it. We call it wheel renderer, so that we are overwriting something, and then let me just set this to like what do we do? We're gonna have a single wheel, like a scout wheel. Scout wheel. Block out. Blue, whatever, something like that. Yeah. So what this should now do is we should no longer see the wheels. We should see a single wheel, like in the center of the vehicle. But we should no longer see the wheels because we have replaced the wheel renderer component. At least that's my theory. Look at this. Look at this. It just works. We can still see the suspension. We see no wheels. We should be able to see the debug drawing of the wheels because that's just drawn by the physics engine rather than the wheel renderer. So, pretty cool. Of course, this object is like nothing to write home about, but like this opens up so many possibilities, both for myself and for mod writers to just do fancy new things, right? And of course, it should just be like if you just want to start with the scout, you can just do this. You can just remove everything and save. And now if we spawn one of those guys, we should just get a normal scout. And then you can sort of piecemeal start just removing things, replacing things. That's cool. That's cool. So the only thing I need to really do to have an empty component thing there is to probably add that to the editor as some kind of special component, and then in the blueprint manager code where we do the flattening, come on, go there. When we do the flattening here, basically we just check. Let's have a look here. It is. We see that okay, this thing is actually replacing or overwriting. and then do a check here, for example, between these two. Is this one of those special empty component thingies? And if it is, we don't actually assign anything here. Instead, we remove it. Right? Then the empty component will be removed. That's actually going to be like slightly trickier though, because yeah, we can't iterate over it here like in this way. If we start removing these things that are in front of what we currently are sitting at, then these indices are not going to match anymore. So probably what I will what I will do here is that I will just quite simply mark these things for removal. So I have like, you know, like a vector of size t's marked for removal or something. I could probably just be like a static vector and have it be like, I don't know, 32 or something. I need to include that for it to make sense. Well, anyway. And then here go like if empty component, which will depend on that special new type, then we just do mark for removal push back j, like so, and then at the very end here we just iterate over the mark for removal and remove them from the list. That's probably the easiest way to do it without breaking the logic. Yeah, something like that. It's gonna be good. It is going to be good. Okay, awesome. This, I don't know how watchable this was. We were pretty solidly in game engine boilerplate land today. Once again, I should probably say. But this was basically exactly what I wanted to achieve. So in that sense, it was a great success for myself. Hoping it was at least a little bit interesting as well. But I think we're gonna probably end here. Thanks to everyone who came to hang out. Thanks to those of you who stuck, even though we had a little bit of internet connectivity issues there in the middle of the thing. Sometimes that happens, but if this is interesting to you and you want to see more of it, there's actually a whole lot more of this already in VOD form on the channel, so do check that out. All of these streams go up as VODs as well. And all the normal YouTube jazz, like, subscribe. If you want to play the game today, you can do so. Just join the Discord server, and on the announcements channel you can find Pre-Alpha 2. And especially if you want to if you think it looks fun and you want to start modding the game, then do come hang out there, because I'm hoping to make that available to you later this year still. The first sort of playtest version in Steam that would have mod support. And that's partly because of that I'm now trying to solidify these things. So do check out Discord, and of course check out the Traction Point Steam page as well. You can see the link there in the beginning of the chat, and I've just actually pinned that message. I don't know exactly what the chat looks like now after that whole disconnection debacle, but hopefully it's visible to you, and you can also see it in the description. Do go check out the Steam page and wishlist the game. It really helps the project along. And with that, I wish you a continued nice weekend and beginning of the week. See you in the next stream. Have a good one. Bye.